want to use a razor blade to get 3 samples from each treatment. We do this to ensure variation among both treatments. This is a pressure bomb made by PMS Industries in Albany, Oregon. This pressure bomb measures water potential, and if done pre-dawn when the stomata are closed, is a great measure of plant water stress. The gas used in the pressure bomb is nitrogen, which we attach in this port here, ensuring that no circles are shown and that the connection is good. Turning on the gas tank, which you would need to keep on the ground. Using our clippings, we insert the end of the leaf in here. Attach it to the pressure chamber. The gas that is input here will release pressure as I change it up through, and should be exerting a force on the leaf. And the certain force in millibars of gas that pushes the water out is the leaf water potential. So we're NBA finals start. We struck oil. Reaching your measurement, you want to turn this nozzle all the way to the right in order to release the pressure that we've built up in the gauge. Yep. So when you're done, you want to close the valve on the tank, release the pressure within the tube here by turning this, and then you're able to release the end of the tank from the PMS machine.
So this is a fairly dead looking, sad looking hazelnut. We're going to try a hydraulic conductivity measurement, and we'll demonstrate that now. We're also going to take a hydraulic conductivity measurement tomorrow morning after soaking overnight to gain a measure of maximum hydraulic conductivity. And we can also take a cavitation measurement, although we're not going to do that for this video.
So the scale is attached to the computer, and every time that, well, it's measuring every 5 seconds, so we're getting how much water is coming out of the sample, and it's being recorded onto a file on Excel.
So we're on set here in the lab of Carlos Gonzalez. Here we have Chris, and he's going to show us how to do hydraulic conductivity. Okay, go for it, Chris.
So what we have here is 3 samples of the hazelnut plants that we're doing this research experiment on.
Mm-hmm.
What we did was cut samples from the stem of a deceased hazelnut plant, and we let them soak in water overnight, in DI water overnight, to ensure that they're saturated. What we did here was we applied the rubber tubing that we're going to connect to the hydraulic conductivity, not machine, but mechanism underwater to ensure that there's no air penetration on our sample. So once we've done that, we clamp down to ensure that there's no leaking. The way that you can tell that there's no leaking is by filling the sample with more water, and you can see the meniscus that forms here. We've already tested it on the other side. So this is airtight and sealed. So here we have DI water that's going to run through at a height of 1 meter down through the sample and to our measurement device here. This is going to calculate the change in weight over a period of time, which then is calculated by an Excel spreadsheet developed by Carlos in order to calculate the hydraulic conductivity of our samples. Our samples have not been placed in a vacuum chamber, therefore they have whatever existing embolism was present when we cut the samples. So we'll do these measurements, then place the samples in a vacuum chamber, which is over here, overnight, which will rid the samples of embolism, and then we will get the maximum hydraulic conductivity. So here, what's important is you don't want to get any air in your sample, so we have syringes with DI water, which we will be flowing water through once I get it right. And, oh, wrong side. So you want to just make sure that there are no air bubbles in there. And then the same on the other side. Probably should take them more. We're good. So you can turn these to off, take these out. You want to place a wet rag on the sample for reasons I forget. And one important thing is the height of the water, which you are going to want to input into the Excel spreadsheet along with the length of the sample as well as the area of the sample. So all of those have already been measured and placed into the Excel sheet to ensure that our outputs of hydraulic conductivity are correct. Then the last thing you want to do is open up this pathway, and water will flow through the sample